Hello, so we are going to talk about removing data from a linked list. So data removal is another very common and very useful operation in linked list. Right? It kind of does the opposite of adding data. So what it takes is that we have to look at all the data in the list, find the one that we want to remove, and remove it. So whenever we think about looking at all the data in the data structure, then we should kind of think about, okay, can we again use the dunder iter in removing data, right? So and oftentimes the answer was yes, but in this case it was no, because uh, if you recall, dunder iter kind of it gives us the data, right? It gives us the data attribute in each of the node. But what remove requires is that we are going to have to change the structure of the linked list, right? So that would require manipulating the next attribute. So an alternative is, yeah, we can write a version of Thunder iter that will return the nodes, and from the nodes we can get to the next attribute, but that's kind of outside the scope of this class. So anyway, so we're not going to use well, we won't be able to use Thunder iter for remove. So let's see what we have to do pictorially. So this is just kind of in the middle of a linked list, and let's say we have a pointer, we have the current pointer, and we want to remove the node that is pointed to by the current pointer. Now this is really what happens when we remove the node pointed by the current pointer, and that is we change the the next pointer of the previous node to point to the node that is pointed to by the current next pointer, right? So this is something very, very important to realize, is that when we want to remove a node, we have to have access to the node before the current node that we want to remove, or at least in the way that we implement our linked list. I mean, there are doubly linked lists for which this is not a requirement, but we have a singly linked list, and we again have to have the access to the previous node in order to remove the current node. Okay, so anyway, so that's kind of what happens pictorially. Let's try to write this. So we have to have a previous pointer and we have to have a current pointer. The previous pointer should be a none. The current pointer, as usual, we start at the head. So we're going to walk down the linked list. So while current, if data equals to the current node's data, then we find our node, and basically we have to change the previous next pointer to point to the current next pointer. And that's if that line of code doesn't make sense to you, look at this picture again. This is exactly what happens. Is the previous dot next is assigned the current node next. And since we remove a node, we should kind of change the size. We decrement the size, and then we're done. Okay, if the data is not equal, then what we should do is just to move the previous to the current one and the current one to the one after the current one. So the previous and the current should be previous should become the current, current should become the current dot next. And if we reach the end of the while loop and we didn't find the data, then we should just raise the key error as we did in the find case when the data is not found. So, okay, so that's the implementation. Now we should test it. So for this testing, since this is a more complex piece of code, I want to do a more exhaustive or complete test. So let me tell you what I'm doing here. So again, I just have a setup of a list of data, and then I allocate our own linked list, and then we insert all the data into the linked list. And what I want to do is actually to remove each piece of the data from the full list and make sure the remaining list contain the remaining items. So that's why I have a for loop here that I'm going through all the numbers in the list. Okay, now in order to I cannot reuse the same L and the same linked list over and over, because every time I'm going to modify them to remove something from them. So instead of modifying the original, instead of removing from the original L and linked list LL, I'm going to make copies of them. So I'm going to make a copy of L, call it L copy. I'm going to make a copy of LL, call it LL copy. And I'm going to remove I. Again, I is one of these numbers. I'm going to remove I from the Python list. Python list support remove. And then I'm going to remove, this is our remove, our linked list remove, also the same I. Right? And also remember, again, due to the way we add to the head, our list ends up kind of the reverse of what the Python list of data is. So that's why I reverse the copy. Okay, and then after I've done all of that, I make sure after the item is removed, the L copy is the same as the LL copy. And then I also assert that their length is exactly the same. Okay, so let's run this. And it, well, fails, but it failed. Okay, so here I actually printing out which item we're removing. So we're going down this list, we're removing 1, 202, 33, 64, and 5. And the first 4 actually all succeeded. It's when, because they, I mean, I don't see a, because I see these messages printed out, right? It's when we remove 5, which is the last item, or if you think about it, it's the first item in our linked list, and it fails that, and it fails at this line of code. It says none type has no attribute next. So we're trying to get a next here, and one of these is none. So why is that? As a matter of fact, this is actually a very, very common bug when writing linked list. So I actually would like you to kind of pause the video and try to figure out why it fails, and if you can fix it. All right, so let me show you what exactly is the problem. The problem, again, our clue is that in this case, we're removing 5. 5 is at the head of the linked list. And when we're trying to remove the head, the first item, basically we're removing 5. 5 is at the head. That current is actually the head. When current is the head, what is previous? Well, previous is none. So that's the problem, right? What we are trying to dereference a none pointer or object reference and trying to get its next. And so what we really should do in this case, since we cannot change the dot next attribute of a none object, what we really want to do is to change the head so that the head will point to the current next. Okay, so what we really have to do here is if previous is not none, then we can do this. Otherwise, previous is none, then we're at the head. So we're going to have to just say head equal to current dot next. Okay. Hopefully that makes sense. And let me run this. And now it succeeds all of them in removing every single item. Okay. And obviously, one more test we have to do is make sure when we're trying to remove something non-existent, that it also raises the key error. So let me run that, and yes, that also passes. Okay, so that's how we fix the problem. And so just want to say a couple more words about removal. So the important lesson here is when we're dealing with linked list, you have to be very cognizant, very careful, especially about corner cases that involved these special object references or pointers, such as the head. And another thing I want to point out is that our remove data remove only the first occurrence of data, but linked list can have duplicates, right? So if there are multiple copies of data in this linked list, we won't remove the rest. I believe it's fairly simple to implement removing all occurrences of the data. I haven't done it myself, but I think it will be a good exercise that shouldn't take a whole lot of your time to try to implement that and test that. So please do that if you have time.